I teach geology, and it's a complicated planet, so there's a lot to talk about. Like all teachers, I have a hard time deciding how to use class time. Our goal as teachers is to help you develop the skills to study the world so that you can make conclusions. It is not our job to tell you what the conclusions are, which means that during class time, I try not to give specific advice or to talk about myself. Discoveries about the adventures that you are on. I want you to think about how you benefit and how the world benefits from you having gone to Northland College. In fact, let's start with the big story of the Earth. I want to start here because Earth's story is, of course, the backdrop to all stories, mine and yours and everyone else's. It's always important to see the big picture, so this is a good place to start. Let's go back to 4.6 billion years ago, when the materials that make up the Earth and everything on it, including us, came bombarding in from space to make a seething mass of magma. This scene only lasted a relatively short period of time in comparison to the long history of the planet. Quite quickly, a crust of rock formed on the surface, and there was liquid water. We know this because of evidence contained in the oldest crystals ever found on Earth. There are
Hello and welcome again. Sorry for the audio problems, hopefully we'll be getting that fixed. I'm Abigail, a senior and NCSA co-president. NCSA is delighted and honored to introduce Professor of Geoscience, Dr. Tom Fitz, for the class of 2020 last lecture, titled Living a Good Life on a Crazy Dynamic Planet. Thank you, we hope you enjoy, and congrats, seniors.
Hello, bonjour. I'm Tom, and I want to thank the students for inviting me to give this lecture. I am honored, I am pleased, and I am saddened to be giving the seniors their last lecture at Northland College. I teach geology, and it's a complicated planet, so there's a lot to talk about. Like all teachers, I have a hard time deciding how to use class time. Our goal as teachers is to help you develop the skills to study the world so that you can make conclusions. It's not our job to tell you what the conclusions are, which means that during class, I try not to give specific advice or talk about myself. But this lecture is not a class. So I'm going to give you some of my big conclusions about the world. I'm going to give you some specific advice about how to live a good life on a crazy dynamic planet with a lot of other people. I'm going to tell you some stories from my life that might be helpful to you. But ultimately, you have to make your own discoveries about the adventure that you are on. I want you to think about how you benefit and how the world benefits from you having gone to Northland College. So now it's time for some stories. And since I'm a geologist, I like to tell big stories. In fact, let's start with the big story of Earth. I want to start here because Earth's story is, of course, the backdrop to all stories, mine and yours and everyone else's. It's always important to see the big picture, so this is a good place to start. Let's go back to 4.6 billion years ago, when the materials that make up the Earth and everything on it, including us, came bombarding in from space to make a seething mass of magma. This scene only lasted a relatively short period of time in comparison to the long history of the planet. Quite quickly, a crust of rock formed on the surface, and there was liquid water. We know this because of evidence contained in the oldest crystals ever found on Earth. They are zircon crystals from Western Australia that have been studied by Professor John Valley and his students at the University of Wisconsin-Madison. That crystal is 4.4 billion years old and tells part of Earth's oldest story. The ratio of uranium to lead in the crystal tells us how old it is, and the ratio of oxygen isotopes tells us that the rock it came out of had to have interacted with liquid water 4.4 billion years ago. The initial crust of the Earth was made of rock that looked like this one, a volcanic rock called basalt, with these pillow-shaped structures that indicate that it cooled off underwater. This outcrop near Marquette, Michigan, is a remnant of that ancient crust. It's more than 3 billion years old, among the oldest preserved rocks anywhere on Earth. And here we are, a crew of field geologists, napping on those beautiful pillows on a beautiful spring day last May near Marquette, Michigan. When this rock formed, there were no continents. As far as we can tell, the whole Earth was ocean with volcanic rock forming on the ocean floor. This scene is in Wind River Canyon, Wyoming, where the Wind River has carved a deep gorge into the Owl Creek Mountains and exposed rocks as old as those in Marquette. The black rocks at the bottom are pillowed basalt flows just like those in Marquette, and the pink is granite. The granite is slightly younger and tells a different story. It represents the beginnings of continents. And the formation of continents was an important step leading up to what's going on today. The formation of continents is part of the ongoing story of Earth's evolution. And an important process in the evolution of the planet is that rocks melt, they move upward, and they crystallize. They change as they move up, and the result is a wide range of rock types. Earth has an amazing array of beautiful rock types on it. Earth has gone through 4.6 billion years of constant change, and that change continues today. It's not just in the past, it's taking place all the time, all around us. And it isn't just the rocks that have changed and moved. The ocean and the atmosphere have come to the surface through volcanic processes as well. This enormous process of the planet separating into core, mantle, crust, ocean, and atmosphere, has brought carbon, nitrogen, phosphorus, and all the other elements necessary for life to the surface. And changes continue here at Earth's surface. When rocks are broken apart and moved around by water, they go through other changes. These changes during weathering and shifting are like a giant distillation process. And one of the end products is sand, specifically quartz sand. The late Professor Bob Dott, a well-known geologist who taught at the University of Wisconsin-Madison, spent his career studying sand. And he said, "I have come to regard quartz sand as the finest of nature's distillates. It had to go through hundreds of millions of years to be distilled down to pure quartz sand. The finest of nature's distillates." And the creation of sand is just one of many of Earth's many great cycles. This diagram shows the rock cycle, which is the recycling of Earth materials over very long periods of time. These great cycles are called biogeochemical cycles because they involve the movement of chemical elements through interconnected biological and geological cycles. And the great biogeochemical cycles come together most dramatically in soil. Soil is part earth, part atmosphere, part biological organisms, and part water. It is rich with all of the resources needed by life. And this zone, from the bottom of the roots to the top of the trees, has become known as the critical zone because this is where so many of life's resources come together. And soil is our most direct connection, one of our most direct connections to the earth, because that's where our food grows. The calcium in our bones has been on a 4.6 billion year journey through the rock cycle. And very recently, it was weathered out of rock, incorporated into soil, and then the calcium was taken in by a spinach plant, and you ate it. So you and me and everyone else is part of these great ongoing biogeochemical cycles. That is the reference frame that geology gives us. A long history of change leading up to what is going on right now. And we are part of that history. And the story continues. Which leads me to my first piece of advice, and that is, don't forget our connection to the natural cycles that keep us alive. I want to mention that those are the hands of graduating senior Kaylin Hall touching the beautiful, well-cared-for soil at Hermit Creek Farm. The ongoing story of Earth's evolution is beautiful in itself, and it enriches your life to understand your surroundings, such as mountain ranges. This is Mount Moran in the Teton Range of Wyoming. Once when I was studying geology there, someone asked me if it detracted from the beauty of it to be so analytical about the scene. And my answer was no, quite the opposite. I concluded that the more you know about something, the more you see in it, and the more beautiful it becomes. Everyone who looks at that scene is in awe of its beauty. But if you understand the amazing history represented in the rocks and the landscapes, and the forest and the wildlife, it becomes so rich that you can't help but be in awe, not just of the scenery, but also the story. So that is my second piece of advice. See the beauty. Okay. Pay attention to the beauty in the world around you and be curious. Learn about it. And notice that it is beautiful at all scales. In this case, I'm talking about spatial scales. So here we have a view of a thin slice through some sand grains viewed down the microscope. And the photograph on the left was taken by senior geology major Trish Bachmeyer with our petrographic microscope here in the geology lab as part of her senior research project. And the photograph on the right was taken by the Apollo 17 astronauts as they came back from the moon And that was the first full Earth photograph ever taken, 1972. Being able to zoom in and out and get different perspectives is very important. The sand grains and the Earth in that last picture are a physical example of something that I think is especially important that you get from your education. And that is the ability to change perspectives. At Northland, you've been studying the liberal arts. That does not mean that you are becoming liberal. It means that your education is liberating. Education that liberates your mind to be flexible, to see different perspectives. I like to call this flexibility of mind. There is a lot of emphasis in society right now about the economic benefit to an individual of getting an education, and that is important. And many studies have shown that over your lifetime, you make more money if you earn a college degree. Right now, you are probably feeling anxious about graduating into the worst job market since the 1930s, and it will likely be bad for a while. But things will change, okay? This pandemic will end, and in the long term, you will have employment and career opportunities because society needs your skills in thinking and communicating clearly, needs your ability to see things from different perspectives, and needs your compassion. So having an education will help you in your career, but it will also help you work on making a just and sustainable society. And it will enrich your life by helping you see the beauty in the world. One of the ways we need to be able to change perspectives is with time. And that is something that geology gives us, a different view of time. This is an outcrop of sedimentary rocks near Cody, Wyoming. The red layers of sandstone in the bottom were deposited, solidified into rock, and then they were tipped on an angle, and then eroded to almost a flat surface, and then the light layers of gravel were deposited on top of them. Each one of those processes took a long time. It occurred on a time scale that is far beyond our perspective of time. To be able to understand what happened here, we have to stretch our minds into a different perspective. And that is my third piece of advice. Be able to change perspectives into different spatial scales, different time scales, and very importantly, the perspectives of different people. And not just people today, but also people who lived before us and handed us the world that we live in, and the people who aren't here yet that we will be passing the world to in the future. Gaps in the rock record like that are called unconformities. And the difference in age between the rock on the bottom and the rock on the top is about 190 million years, which is a fair amount of time. But this unconformity that we studied in Michigan last May represents an 800 million year gap in the rock record. That's a long time, even to a geologist. A lot can happen in 800 million years. The thing about geologic processes is that from our perspective, Earth seems unchanging. But the geologic activity that led up to today is still going on. These mountains are still going up. And on a geologic time frame, they were going up very fast. These are the Teton Mountains of Wyoming, and they have been uplifted in 0.1% of Earth's history. So you could look at those mountains and see them as ancient, or from a geological reference frame, you can see them as evidence of how dynamic this crazy planet is. The uplift of mountain ranges is one manifestation of the huge processes that operate on Earth. It's all one big interconnected system that seems to move slowly from our perspective, but that's when we get in trouble, when we don't see it from a different perspective. Because the Tetons aren't rising slowly and steadily. They're being uplifted on a fault. And like most faults, it moves in a jerking fashion, one big earthquake at a time. And this is an example of what can happen when we don't see the longer view. This is the Cypress Street viaduct in Oakland, California, after the Loma Prieta earthquake in October 1989. 42 people died under that bridge. So let me ask you this. Is it a disaster when a fault moves? The San Andreas Fault began moving after a rearrangement of the tectonic plates 33 million years ago. And it's been locking and breaking ever since. 33 million years. Is that a disaster? Well, this picture does show a disaster, but the disaster occurred when the bridge was built, not when the fault did what the fault has been doing for millions of years. The disaster is when we don't pay attention to different perspectives of time. And that leads to my fourth piece of advice, and that is, don't let a predictable Earth process mess up your life. Here is the earthquake hazard map from the United States Geological Survey. If you need to live in one of those areas shown in red or purple, be wise about where you live so you are safe as you can be, because powerful earthquakes are coming. There's no doubt. A lot of people ask, when will it happen? And I have two answers. One, soon. Soon enough that you shouldn't just move to an area of seismic risk without doing some research on where you're going to live and work. And two, does it matter if it happens today or in 50 years, if thousands of people are killed when it happens? We want to keep people safe today and in the future. Earthquakes are just one example of many hazardous Earth processes. This photograph shows a suburb of Houston, Texas, after Hurricane Harvey in August 2017. It's easier to predict where a flood is going to happen than it is to predict the effects of earthquakes. So my advice is don't own a house in a low-lying area. Please, don't graduate from the leading environmental liberal arts college to have your life messed up by a predictable Earth process. There are resources available to help you, and if you have questions, please email me or my colleague Dave Ullman. We would be glad to help you. These are geologists studying earthquake records and drill cores of rock extracted from the San Andreas Fault. They're studying the strength of the rocks to see how much stress it can withstand before it breaks, and then to see how it breaks. It's complicated. And although there is a lot we don't know, we know enough to be able to give good advice about earthquake hazards. Which leads to my fifth piece of advice, and that is trust in science. Science plays important roles in our lives, but we often disregard the messages from scientists. And I'm not just talking about scientists in the lab. I'm talking more generally, trust in reason. Be aware of when your thoughts are driven by emotion and when they're driven by logical thinking. I'm not saying that emotional responses aren't important, because they are. But if you make decisions about risk management, for example, like whether or not you should wear a bicycle helmet, use rational thought. You spent 4 years at Northland College developing your mind. So protect your investment. Wear a helmet every time you get on a bicycle. When I told the story about Earth's history, I just gave you the story, the conclusions. I didn't give you all the data. But I promise that the story I told you, all of it, is based on facts, not alternative facts, not emotions, but measurements of rocks. Lots of different measurements by different geologists. Lots of geologists. It's amazing what we've been able to accomplish with rational thought. For example, how to figure out how to read the rock record. It sure is pretty too, isn't it? That's the west side of Sheep Mountain in Wyoming, where we go geologic mapping and tell the story recorded in the rocks in that region. It's an amazing place. But not everyone has had enough practice separating their emotional responses from rational responses. Some people won't believe scientists just because they are scientists. This is a protester in Connecticut protesting recently about the stay-at-home order. In 2014, I found naturally occurring asbestos in rocks that were going to be mined. And a lot of people didn't believe me. Maybe it's because they didn't want there to be asbestos in the rocks, or maybe it was just because I'm an expert. I don't know. But it made me sad, because all I want to do is teach people about the earth and their relationship to it. So how do we deal with this? What should we do when the safety of everyone depends on people's behavior in challenges like preventing the spread of a virus or slowing the rate of climate change? There's no doubt that the coronavirus has brought science to the forefront, and it's going to be interesting to see what happens. These are scientists working in a lab developing a vaccine to the COVID-2 virus, and we need a vaccine. And we need to administer it to everyone that we can. We need to be patient, though, and let the scientists do a thorough job so that we know it is safe and effective. And it will likely happen. Progress is being made in labs around the world. We'll get there. This pandemic will end, and then we'll be able to get together again, and I look forward to seeing you then. It isn't just lab sciences that are important, though, in the development of vaccine that can help us right now. It's also other parts of the liberal arts, such as history. We've been through a viral pandemic before, and we shouldn't ignore the evidence of how that virus spread through society in 1918. Again, it will help us if we change timescales and learn from the past. There's a lot of division in society right now, and it's troubling, because we have to work together if we're going to solve these big problems. The coronavirus has brought a lot of division to the surface. These are anti-vaccination protesters at a rally in Sacramento, California recently. And there's a lot going on in this picture. There's a lot to think about. One thing to keep in mind is that these women are protesting because they want to keep their children safe. They think the best way to keep their children safe is to not get them vaccinated. The overwhelming evidence tells us that they are wrong. But it's important to keep in mind what their motivation is so that we can connect with them about keeping children safe. Right now, at Northland College, we are teaching a seminar on the pandemic, and we've heard the perspectives of lots of experts. Last week, Professor Kevin Shanning talked to us about misinformation and how to make sure the information we study is accurate. He addressed the issue of how to deal with division, and he said, first connect, then correct. So first, find common ground, for example, that we all care about our children. Then get into a discussion about how we can best do that. But how can we do that if people won't listen to reason? I don't know for sure, but it's become clear from the climate change debate, which isn't a debate about science, that we can't convince people with more evidence if they haven't had practice dealing with evidence. These are complex issues, and to solve them, we need to work together. And to do that, we need to be able to change perspectives and have compassion. That leads to my sixth piece of advice, and that is have compassion. We'll be able to achieve more if we work together than if we fight over our differences. It also highlights the importance of being part of the solution. Our individual actions are small, but they add up. At Northland, we like to spend as much time as we can on Lake Superior, and one of the ways that we do that is in these big Voyageur canoes like this one. That boat weighs 300 pounds, and there's no way you could move it down to the lake yourself. But if all 10 people who are going to ride in the boat help out, then each person is only lifting 30 pounds, and it's quite easy. That leads to my seventh piece of advice, and that is do your part. And one of the ways that you can do your part is by voting. And even in this talk, I'm not going to tell you who to vote for. You have to make that conclusion for yourself. But I will ask you that when you go to the voting booth or you fill out that absentee ballot, that you put your liberal arts education to work. You zoom out and you see the interconnectedness of the world, and then you cast a vote that is based on a combination of rationality and compassion, not on selfishness or ideology. I'm going to tell you a personal story about the biggest, most challenging event in my life. I was an active kid. I grew up running around outside in the apple orchards of eastern Massachusetts, and I loved to run. I ran cross country and track in high school and college, and I enjoyed being fit and strong. This picture was taken when I was a junior at St. Lawrence University in New York, and I'm smiling in that picture because I'm looking at the finish line at the end of my first full marathon. And when you run your first full marathon, you don't know what you're getting into, so the sight of the finish line is sweet. Then, a few years later, when I was working on my PhD at the University of Delaware, I found a rash like this one on my belly. If you ever see a rash like that in your skin, go to the doctor right away and get an adequate course of antibiotics, because that is a Lyme disease rash. I did go to the doctor right away, even before the rash got that big, and I got the treatment. But Lyme disease is strange. It's a bacterial infection that in almost all cases clears up with the first adequate round of antibiotics. But in a small percent of cases, such as mine, the symptoms linger or come back. It was bad. I was weak, I was in pain, and it went on for several years. Doctors couldn't help. I'd been healthy and strong my whole life, and then that strength was completely taken away. It was the hardest thing I've ever faced. I don't know what was wrong. It probably wasn't just one thing. But I do know how I got better. I just took really good care of myself. It happened slowly at first. I got enough strength to exercise a little, and then I could sleep better, and then it started to happen fast. And after a few years of weakness, I got my strength back in just a few months. I finally finished my PhD, and I got this job at Northland College. And I pretty much haven't stopped smiling ever since. And that leads me to my 8th piece of advice. Take good care of yourself. And this is what you need to do to take care of yourself. Get plenty of sleep. It is time for your mind and body to heal. Exercise. The mental and physical benefits of exercise are amazing. It was the centerpiece of my life before Lyme disease, and then it saved my life in the aftermath of Lyme disease. I like to say that exercise is the key to a good life. And it's part of the liberal arts to have a healthy mind in a healthy body, as Professor Michelle Small likes to remind us. Thank you, Michelle. And love. You need to have people that you care about and that care about you. It's also about loving your own life, loving what you are doing so that when you wake up, you're excited about the day, or a lot of days anyway. I guess that can't happen every day. And food. You have a lot of control of your physical and emotional well-being by the foods that you eat. Eat well and pay attention to what foods work well for you, because we're all different. Take good care of yourself. A healthy mind in a healthy body. It's so important. It has to be the starting place for a good life. I have a small issue remaining from the aftermath of Lyme disease, but mostly I'm fine. In fact, I'm strong. And I intend to stay that way as long as I can. This is me in the Chequamegon 40-mile mountain bike race last year. And I do a lot of racing for fun and fitness. I do okay in races, but I don't really care how I do in comparison to other people, because for me, it's a party. It's a celebration of health and fitness. Take good care of yourself and have compassion for those people who are struggling with their health. I want to end with some thoughts for which I need to go back to the geologic record to broaden the view. This is a beautiful outcrop of quartzite at Devil's Lake State Park in southern Wisconsin. It has ripple marks on the top that were made in sand on a beach 1.7 billion years ago. It makes me think of what author John McPhee wrote in his book Basin and Range about the geology of Nevada. And that is, if you free yourself for a moment from the typical reaction to a quantity like a million years, you free yourself from the boundaries of human time. And then, in a sense, you do not live at all. But in another sense, you live forever. Let's think about that. The first part. In a sense, we do not live at all. Our lives are short in comparison to the big history of Earth. So how does that help you? Well, for me, it reminds me to make the most of my time and to find meaning in my work and my relationships. The second part of that, in another sense, you live forever. The carbon, hydrogen, and oxygen in my body came together in a way that gave me consciousness. And here I have a few decades to witness and understand this amazing story that I'm a small part of. And that is beautiful in itself. And our lives are an opportunity to help make the world a better place for today and tomorrow. We can make a difference. Maybe not forever. Forever is a long time. But the work that we do can benefit those who come after us for a long time. When I was a 19-year-old sophomore in college, I learned about the beauty within rocks and landscapes. But I didn't realize that one of the main reasons I became a geologist was spiritual. To me, reading rocks is a spiritual endeavor. In my opinion, rocks are the biggest and the longest record of what God, the Creator, whatever you want to call the life force, has done on this planet. Science and religion are sometimes seen as being at odds, that they have incompatible explanations for the world. But they shouldn't be at odds because science leads us to see and understand the world. It doesn't give it meaning. And I think that the big questions and the real beauty in life is at the intersection of science and religion. This is my big question. How did love come out of the rocks? I don't know. I don't know how it happened, but I know that it did because it all started as a bunch of meteorites 4.6 billion years ago. When you study geology long enough, and you start to understand what has happened on this planet through billions of years, you get a sense of the big picture. And then you see how alive this planet is. It's alive with interconnected biological and geological processes evolving together through the eons. It is profound, and we are part of that grand story. I think about all the history and process that has concentrated the elements into us, and I want to borrow Bob Dott's line and say, I have come to regard love as the finest of nature's distillates. And then I think about what really matters, and I conclude that what matters is that people have good lives. We can help make that happen by having compassion and understanding our connection to the earth and to each other. This is the Earthwise photograph, one of the most influential photographs ever taken. It was taken on December 24th, 1968, by the Apollo 8 astronauts as they came around the moon and their view was toward the Earth for the first time. It was the first time that people had seen the Earth from a great distance. 1968 was a time of great turmoil. It was the height of the civil rights movement. We were torn apart by the Vietnam War, and the vast impacts of air and water pollution were first being recognized. And there it was, a message from space on Christmas Eve. And the message is that it is a finite planet, and we are all on it together. That message from space on Christmas Eve, 1968, is very relevant today as a virus spreads around the world. We have significant challenges facing us today, but if we work together and put our hearts and minds to work, we can get through a pandemic. And we can make a bright future for ourselves and for the children we don't know because they aren't here yet. When I lead field trips and spend time in the field with students, I always come to the conclusion that my life is rich with amazing rocks and people who have taught me so much. And a lot of those people are graduating from Northland College this weekend. And I want to thank them for enriching my life and making the world a better place. I took this photograph on the second day of classes in fall semester 2016 when you guys were freshmen and the Superior Connections crew hiked to Carolyn Lake Bog on the second day of classes. You and all of your classmates have learned a lot since then, and you've enriched this community. Thank you. Miigwech. Take good care of yourself and other people, and stay in touch.